In the name of God, we start the 5th session. Muhammad Rashid Mahdir wrote, the problem is now we have two sides, one in English and the second in Persian. Yes, and Naima wrote, in LMS there is a problem. I contacted Sarah Al-Husseini. The problem was not resolved. Please help. As you see, Naima said that, you see, I also have this problem with English. You know, I can't access the address is LMS 401 araq.ac.ir. I don't know why I can't reach it. But fortunately, I can access to engineering department, the LMS of engineering department, and you see all the documents and sessions are in Persian. Anyway, when I access to English, I upload this document there too. Yes, this is LMS International, but I don't know why. At first I must access to this, and then after that I must choose the international LMS. But it doesn't work for me. I don't know why. Okay. Now listen. We review what did we say before. After course introduction, we learned something about the fundamentals of machine learning. Then after, we started computational methods for data analysis. Then we studied time frequency analysis. We studied and discussed about Fourier transform and wavelet. At this session, I think and I hope to finish this topic, image processing and analysis, because it is too easy and I think you passed this course before. But for reviewing and to know again something, we study it in fast way, and from the next session we will start linear algebra and singular value decomposition. It is too interesting, and then after that principal component analysis. Anyway, this session we want to discuss about image processing and analysis. Then our way in this session is so clear. Okay, this topic is related to reference C, part 3, and chapter 14. Chapter 14 is image processing and analysis. Okay. Our main reference in this topic is chapter 14 of part 3 of reference C. Okay? Okay. And of course, I wrote the name of the reference here. Okay. This is related to reference C. Oh. At first, we must be familiar with basic concept and analysis of images. All things is clear for you? Okay. No question? Okay. I'm sure your opinion, your idea is like me. Most of time you understand, you see that maybe one image is so worse than many sentences. I mean, instead of saying a few sentences or some sentences, to say your idea, to say your goal, instead of writing, talking, speaking, only you need one image. And by graphical figure, by an image, you can say your idea about any topic. Okay? Then image is so valuable in this field. And beside this, we have many digital images in many different fields. For instance, in air, in medicine. We have many images. The images of brain, the images of heart, the images of country, the images of body skeleton. These images help the physicians to diagnose the diseases, different diseases related to Alzheimer, Parkinson, any neuroscience diseases or other diseases. Then image processing in different fields are so valuable, and it is so good and nice that we learn and we know the algorithm related to image processing. First, we must know, according to this chapter of references, we must be familiar with different type of images. One of them is ultrasound. This image is a image of ultrasound of a baby when a woman is pregnant. Then you know, in different stages of pregnancy, she check the conditions by physicians, and by ultrasound we can learn about the sexuality, about the health of baby. In addition to medicine, we have ultrasonic in other fields. For instance, another imaging that is similar to ultrasound is radar and sonar imaging. They send waves, and then the object reflects it. By the amount of reflecting of a wave, we can reconstruct an image and then analyze, for instance, the distance of a target. Okay. Another field, another type of image is tomography or temporal imaging, infrared or temporal thermal imaging. You know, for instance, this is related to food, to body temperature, and you see the temperature are different in different areas of the body. Okay. If, for instance, if a person with heart diseases, maybe the temperature in the area of thorax is different, or maybe in some disease condition the temperature of face is different, or maybe the temperature of each person, the temperature of face of each person is different. You understand me? The temperature of some, the body temperature of some person is low. In contrast, the temperature body of some person are high. Then maybe this kind of image help us sometimes to recognize some persons, some diseases, and like this. Besides, you have some electrical instruments, okay? When they are destroyed and they don't work well, one of the reasons of this disruption is temperature. Then, if we have a thermal imaging of that electrical instrument, help us to recognize some problems. For example, the place of the disruption. Okay. Another thing is tomography. Tomography is like a CT scan. You familiar with CT scan? At least you hear this word and this phrase. During time, some person developed medical imaging system, and they capture images from different point of view. For example, if this is body, we can get images from this view. You see, I zoom on it. Okay, we can images from this view. For instance, consider you want to get images from the brain. Okay, this plane goes up, and from this point of view, we can see the brain. Or from this view, consider person and interact this plane with the person, with this body. Or you can rotate this plane in this way. Okay, in this way, and then get the images. Okay. And from different points of view, we can get different medical images. For instance, this image is related to CT scan of abdominal of person, and it is related to this view. They called in different phrases, but what is its name is not important for us. Only and you at this moment understand that if we have three-dimensional object like body, we can see in different plane. different planes and get the images from that specific point of view. Okay, one student said that this is called an MRI. It is like MRI, yeah, it is like MRI, but the imaging system is completely different. Okay, we have MRI here also. What is the differences is related to the protocol of imaging system. In MRI, we can see soft tissue, but in CT scan, the hard tissue is better observed. Okay, but the plane of MRI, magnetic resonance imaging, is exactly like this CT scan, like this image. Okay. Another type of images is digital photos. It is like the images and photos that you get by your cell phone, by your camera. They are digital photos. Okay. And finally, computer graphics. There are some photos, some images like this. We can reconstruct images, okay, by digital images like this, here, okay, and then add background, or maybe we have some CT scan from this is related to the spinal part of the body. Okay, by different images we can reconstruct three-dimensional object like this. Okay, and in this way the physician can understand better, for instance, the location of this tumor. Okay, or another application is in brain surgical. If we have a person has a tumor in brain, by different images in different points of view, we can reconstruct the three-dimensional computer graphics of that part of body. And another thing that our images doesn't have the information of depths. For instance, when we see this CT scan, we can understand the depths of this tumor. Okay, but after we reconstructing in three-dimensional, our information are more completed according to this image. And another application in cartoon, in animation, videos, and photos, like Spider-Man and other things. Okay? Any questions? Okay. And now for image analyzing. Sometimes our images are not clear because of different reasons, because of the problems in the imaging system, because of the problems of a person who get the image. Okay, maybe because of the environment condition, we don't have clear image. Okay, then by image processing, we can enhance the images, and we can achieve the better images with higher quality. For instance, we can enhance the image contrast. Imagine this image in the left. By image contrast enhancement with different algorithms, we can achieve this. And I'm sure that you were familiar with this algorithm before. And if you are not familiar, no problem. In noise. We have different noise, salt and pepper noise, white and black noise, different noises. We cannot say that, okay, we have only these 5 types of noise. In different applications, we have different noises. Okay, and then again, by image processing, we can enhance the images. In this presentation, we only want to know the concept of what is image construct, what is image denoising, and other things. Another thing is image deblurring. Again, I have to zoom on it. Sometimes consider the left. For instance, if you want to track a person in a video, in a photo, okay? And because of different reasons, our image is not so clear, and it is like the left one, okay? It is not clear. Okay, the object, or really the object, is not clear. And then we cannot see the face clear. For instance, consider this person. Maybe this person and this person are the same, or this person. Okay? Then, step by step, we can enhance it. Okay? We can blur the image. At this moment, you understand the contrast, enhancement, and the blurring. They are completely different. The blur system, the blurred images is like this. It is not related to construct. Actually, the construct in the left image is too good. Okay, and the construct doesn't change in image 1 and image 2. They are same. The things that changes is the left image is blurred, and it converts to the right. Okay, Okay, another thing is in painting. For instance, in our traditional images, or I don't know, in historical images or other things, in medicine, maybe we miss some information. In image. Okay, we can in-paint this region. This in-painting may be related to the information of the pixels neighbored to this area. And then we have many different methods. For instance, averaging, median, KNN. Okay, we can use different images, different algorithms to do this progress. If we want to know all the methods, then we have to know another course. Image processing, advanced image processing course like this. But in this course, we hypothesize that you know something about image processing, and I'm sure you know. I asked from your professors, and we only want to be familiar with this and review it. And in our project, in our course projects and in exercise, we want to mix all these methods, and we will ask you to doing this exercise. Okay. One student said this is filtering. Yes, yeah, it is like filtering, but it is not filtering. Filtering, if you consider only the word of filter. Okay? What is the filter? Filter pass some information or reject some information. Okay? This is filtering. Yeah? But here, for instance, we use the intensity of pixel around this area and said that, okay, we can averaging this intensity. Or another thing, we select the nearest intensity around this. Okay, one said that we have PowerPoint is related to this. We have it. Another thing, you have reference. C. Who wrote? Hala Hassan Mohassin. I don't know if I pronounce it correct or not. No, another student, Karim Naim, said that all the information of image changed. No. Only around this area that we miss the information. In this concept, only around this. Okay. Another phrase is image segmentation. Sometimes, for instance, again, consider the MRI brain images, and I'm sure you eat the brain of chief. Okay, we called it in Persian kalle pache. Okay, and I'm sure you eat Of course, not human. You eat the brain of some chip, okay? And anyway, there are different area in brain. We call it gray matter, white matter, and other things. CSF is the liquid around the brain. CSF is a liquid around the brain. And some diseases affect only on, for example, white matter, or maybe affect on gray matter. Or we have, if we want to study brain development, the white matter, gray matter, and CSF of a child is different from adult. The volume and other things. Okay? Then, to study and to understand these changes, sometimes we have to segment different parts of brain. Okay? One way of segmentation is to recognize the age. For example, here. For example. Okay? And said that, okay, this is the age of white matter. But it is so time consuming. A person without any works and with good experience and with good knowledge must sit down in front of a computer and with patience, okay, paint this age. But we can do this segmentation automatically, and then said after this automatic segmentation, said that, okay, this red area is related to white matter, the green is related to gray matter, and the blue one is related to CSF. And then said that, okay, this segmentation is related to a man with, for instance, with 15 years old. And then we segment another brain for woman with 15. And then see the differences between the man and woman. Okay? Or maybe we can consider another brain MRI images related to child. From the out of view, you see that the size of a head of a child is smaller than an adult. Then the brain also is completely different. This folding, this folding is also different. We called it folding. And each folding also named different topic or different names. And in different diseases are completely different. One of my major is image processing and neuroscience, and my PhD thesis is about analyzing the brain neonatal. Neonatal means the child after birth. A neonatal brain development, and it is so interesting. It is so interesting topic. Then let's move on. Anyway, we know the segmentation is so important in image analyzing. It is an example of a neuroscience, but also we have many different applications for segmentation. For instance, if you want to track car in roads, At first, you have to know which object is car. Okay, then maybe segmentation is good as a previous main method. Maybe segmentation in that application is like a pre-processing. Okay? Okay. No questions? Okay. One said the sound is, I think the sound is related to your internet and other. Hassan Abbas Sahib said that detects some regions or what? Yes, segmentation is this. Okay. Exactly is like this. And if you see the segmentation breaks up an image into blocks of different structure. This is particularly important for biomedical application as well as military application. Good algorithms for determining segmentation locations are critical and many different. Okay. And what is the rest? Okay, I try to finish it. I try. And what is the mathematical approaches? As you see, there are many different algorithms. But one of the most important of them is morphological approach. Morphological, you hear that we have erosion and dilation. We have opening and closing. Erosion, please consider this structure A. Then we erode this structure. After erosion, we can access this gray area. You see, then we have the separation here. But in the origin, they are connected. It is connected, or the two regions are connected to each other. But after erosion, we don't have it. Okay? Then again, after this erosion, again we dilate it. Dilate means we increase the region. Then we access this. By dilation, you can access two parts. In the first structure in A, we have only one part. But after erosion and dilation, we have two structures like this. And the mixture of erosion and dilation, we called it opening. In contrast, if at first we dilate the structure, consider A, we increase the size, we dilate it. Okay? And then we erode it. Okay? In this example, maybe the result of these progresses are the same at the first. Okay? But sometimes this closing, at first dilate and then erode, help us to achieve a better object. For example, one application is in biometric using fingerprint. This is the images of a fingerprint that maybe you use in each day for your working in some military places, in airport. This is like this. And then identification of fingerprint is so reliable with different other biometric parameters. And then the image processing of fingerprint is so valuable. I am also work in this way. Okay. Another method is Fourier analyzing. We discussed about the Fourier transform in the previous chapter with details. And finally, the concept of the Fourier analysis is to achieve the frequency, is achieved to changes, location changes or temporal changes, and like this. Please consider this object and this object. Okay? Along this direction, don't have any or most important changes. Okay? But now you consider this, or consider this direction, the yellow one. Okay? The changes of pink and yellow are more than blue in some locations. And consider the circle. The Fourier space of this circle is again circle. And another thing, the frequency changes of rectangle and circle again are completely different. And both of them again completely different from the cross. Okay, then sometimes the Fourier analysis is so valuable. For example, another thing is that we have this circles object and we have this pen. By converting and transforming the image to Fourier, we can understand, okay, this area is related to these circles, and this line in the Fourier are related to this pen. Okay, and then after that we can separate the circle, the frequency around this circle from this line, and then after that we can separate and segment the circles from the pen. I mean, maybe sometimes by Fourier transformation we can segment image sometimes. Okay, the time of class is finished. I prefer to stop here. I will record the next slides. It is not so much. I will record it and I will upload it in the LMS for tomorrow sessions. Okay? Okay. As I said before, the sounds is related to the fan of my laptop. Okay? Don't worry about it. You will use it. This. Any questions about the documents, about the what I said? Please ask. Okay? Then again I said, as soon as possible that I access to international LMS, I will upload all the documents there. Another thing is that all the documents in the Persian is in English, then the assessment to English or Persian are not different. The important thing is that you access to LMS. Any type of LMS is good, Persian or English. Another thing, Zahra asked about the project. Yes, of course, why not? You ask. Please ask it. And you mean what is the project? After we finish, you see, yes, it is content programming, surely. Please consider this content that I uploaded in LMS. It is related to time frequency image processing. One exercise is related to this topic, okay? And if you see the books, in the books there are many codes, okay? At this moment I didn't send any exercise to you, but I ask you, for example, use the wavelet toolbox of FDA or Fourier transform toolbox and consider your desired image and images that you want. And for example, I ask you to reconstruct. I ask you, for example, consider one image, add noise to image, okay? And one time you denoise by filtering. One time you denoise the image by wavelet toolbox, okay? One time you denoise the image by Fourier transform. And then see the results, the outcomes of these different algorithms, and compare the results. And write a little report about the outcomes that you achieved them. Okay? No, in MATLAB. Okay, because our reference, this reference is in MATLAB. In the first exercises, we do this in MATLAB. But when we want to study deep learning algorithms, they are in Python. The reference is Python. Then we will do our exercise and project in Python. But now in MATLAB. Okay? Because your main is in MATLAB. The main, Muhammad Rashid Mahdi said that you will be study this in Python. The main goal of this course is, in addition to review this concept, you will be familiar with MATLAB and Python, both of them. Okay? Then the first algorithm is in MATLAB and the last one is in Python. And don't worry about how to do it. I will explain completely in details in the exercise sheeting. Okay? Don't worry about the exercise. It would be like this exercise and example in this book. You have the example in this book. Only you want to sometimes maybe you use these codes. Sometimes no problem. The main idea is that you learn. Okay, I explain you. Don't worry about it. Hassan, Abbas, Sahib. Don't worry. Okay? All of us must help each other in different ways. Okay, any questions? Okay, and from this week, you see we have online and offline sessions.